Alright, what you see here is the very last problem in lesson 22, being question 10. And it says, find the volume contained between the sphere by equation rho is equal to 9. And what's that one we're familiar with? If rho is 9 and theta and phi can be anything, then you get all the points in 3 space everywhere at a distance of 9 from the origin, a radial distance of 9. So that's what that is. And then this thing we haven't seen, and it says rho is 6 cosine phi. So why is that a sphere? Or where is it? Or all the questions that you could ask about that. I noticed that rho varies only with phi. Rho doesn't have anything to do with theta. Okay, and how does rho vary with phi? It says rho is 6 cosine phi. And I noticed that if, say phi was 0, and since phi is a rotation away from the positive z-axis, you would be on the z-axis. And you get this point there at the top, which, what would that be? Cosine of 0 is 1 times 6 is 6. So like right there, rho is equal to 6. Phi is equal to 0, and that puts you on the z-axis in 3 space. Okay, so you get that point. What about the rest of them? And why is it a sphere like that? Well, I mean, how's the cosine curve vary with the angle? Well, cosine curve, when the angle is 0, starts at its maximum of 1. But as the angle goes to 90 degrees, cosine gradually works its way down to 0. So what you see here is when phi is 0, rho is its maximum of 6, but as phi were to get further and further and further away from the z-axis, rho would get smaller and smaller until it's eventually 0 at 90 degrees. Okay, so yeah, right there, that point at the bottom, say, well, rho is 0, and in 3 space, phi being a rotation away from the positive z-axis, phi is pi over 2. So you get that arc right there. Alright, now that's an arc that you'll get directly from this. Why the whole sphere, though? Well, because we can't forget about theta. There's such a thing as theta in spherical coordinates in 3 space, and it would give you all the points around here on top of rho being whatever it is and phi being whatever it is. We get points in 360 degrees everywhere in this direction. Okay, so that's how you get from this arc initially an entire sphere with its center on the z-axis in 3 space. Alright, so that's the way it is. That's what it looks like. Now, to find the volume that's between these two, that's outside of this one and inside of that, we need bounds and spherical coordinates. So let's say here's what it means to be in there. Very easily we can see that theta, anywhere you want between 0 and 2 pi. That's true of every point here. Theta is somewhere between 0 and 2 pi. What would you say about phi? Well, it's like this whole region is above the xy plane, and the rotation phi from the z-axis to be on the xy plane be 90 at most. So let's say pi over 2, and we could have phi be 0, right in here. How do you get all these points? Phi is equal to 0. How do you get all these? Rotate up to 90. And you got all these down here and these in here and so on. Okay, so last, what about rho? Well, I would say whenever you give me theta and phi, whatever they are, I have to go out further than the shell of this sphere, but not further than that one. Okay, so it's like rho's got to be between them. So you could think of it like this, that you're in 3 space and you have spherical coordinates, and you have whatever angles you have, whatever you want them to be that are appropriately like that. And it's just, you give me the angle, that gives me a direction, and I've got to go like that. So I guess you could say, like, if there was a row axis, it's like this, okay? Or phi is like that, theta is however you're turning this way, and then you have to, in that direction, keep yourself between these two things. Okay, all right. Well, that's more than I need to say about it, but that's the truth, and here it goes. What's rho have to be? Bigger than that, but less than this. So let's say 6 cosine phi, and then, but no more than 9. And there you go. So these are your spherical coordinates, your boundaries that will keep you up there. So from here, I need to set up something, some kind of math that's going to give me the volume. And let's see, let's do that here. Like, I want to put it right under that, because obviously I use those boundaries. So the volume is going to be, well, it'd be a triple integral. That's what a volume integral would be if you use spherical coordinates. Triple. And I put 1, and I put the volume differential, which for spherical coordinates happens to be rho squared sine phi, times d rho d phi d theta. Okay, so that'll give me the volume of whatever the boundaries describe. Now, here's what they need to be. So rho first. So let's say 6 cosine phi up to 9. Okay, phi 0 to pi over 2, and theta 0 to 2 pi. And that ought to do it. Okay, so when we do these volume integrals and spherical coordinates, that first one is always going to be the same. And this is a 1. That's rho squared sine phi. Phi is a constant. I integrate with respect to rho, and I just get this. Say rho to the 3rd power over 3 sine phi. So that's an easy antiderivative to get. Whatever this amounts to is a different story, with that being the lower bound and that being the upper bound. Okay, so if I do a little math, let's 9 3rd power, divide by 3, let's say 243 sine phi, okay. And then 6 3rd power over 3, so subtract 72. Okay, and then I get cosine. So that's going to be 3rd power now of phi times sine phi. Okay. Alright, so that doesn't look too bad. I think probably handle that in the next step, no problem. That one's easy to do, and this would be a pretty simple U-substitution, like we've seen many times before. So let's say I don't want to rewrite this whole thing. So what do I do next? I integrate from 0 to pi over 2. That, or here, that's my shorthand to tell you that's what I'm doing with respect to phi. Okay, so about that, this one I think very straightforward. 243 cosine phi, and it's negative. Alright, and then this other one, well, how would the U-substitution work? If U was cosine, du would be negative sine. So that's going to change. Alright. And then I would say that all that works out to be is u to the 3rd power du, antiderivative being u to the 4th power over 4. So 72 by 4, I get 18. And then cosine to the 4th power phi. Okay. So that's not too bad. What do we got to do with this? 0 to pi over 2. Okay, So what's pi over 2 do for you? Well, cosine in any form, fourth power, 243 cosine of pi over 2, it's all 0. So we don't get anything. Subtract, what's 0 give you? Negative 243. Cosine of 0 being 1. And then 18. That looking like 18 times 1 to the fourth power. So I get 243 minus 18, 225. Okay, so we're done with that. Well, that's a constant. The last one is with respect to theta, 0, 2 pi. Well, that's a constant, so it's going to say 225 theta times 2 pi. And we'll get for our third and last integration, so 450 pi. That's the volume. I'm giving you that because there are units, so generically that's volume, units to the third power, and that's our answer.